Welcome to my channel, AI and Automation Tools for Everyday Use. In this video, I want to show you something really exciting. We have successfully built a working robotic arm simulation in Python that can automatically pick up cubes and place them in different locations. This may look simple, but what you are seeing is actually the foundation of a real robotic system. Before we look at what the robot is doing, let's briefly talk about the two key technologies that made this possible, PyBullet and the Panda robotic arm. First, what exactly is PyBullet? PyBullet is an open-source physics simulation engine designed for robotics and artificial intelligence research. It simulates real-world physics such as gravity, friction, collisions, and motion, allowing us to create a virtual world. Instead of building a physical robot immediately, we can first test everything in simulation to develop robot behavior safely and quickly. In PyBullet, everything you see on the screen is created using Python code. For example, the floor and cubes are objects with defined mass and friction. Now let's talk about the robot we used, the Panda robot arm, a real collaborative robot created by Franka Robotics. In our simulation, PyBullet provides a digital model of the Panda arm, including its joints, gripper fingers, and physical constraints. Because of this, the Python program can control the simulated robot in almost the same way real robotic software would control a physical machine. In this project, I programmed the Panda arm to perform a classic robotics task called pick and place. First, it moves its arm above a cube, lowers the gripper, closes around the cube, lifts it, moves to a new location, and places it down. To make this work properly, we had to solve several technical challenges like improving smooth motion and stabilizing objects. I stabilized the cubes so they would not shake while being carried, and created a loop to process multiple cubes automatically. What makes this particularly interesting is that all of this behavior is controlled using mathematics and algorithms. One of the key concepts used here is called inverse kinematics, a method to calculate how each joint must move to reach a specific position. This is the same principle used by real industrial robots in factories and warehouses all over the world. So what we built here is not just a simple animation. It is actually a robot control system running inside a physics simulator. Right now, the robot works because our program already knows the exact coordinates of each cube, but in the real world, robots need more. Robots usually do not know where objects are. They need to look at their environment and understand it first. So the next step in this project will be to add a camera to the robot arm. PyBullet allows us to simulate these visual sensors. Once we have a camera, we can process those images in Python to detect where the cubes are located autonomously. I also want to connect this to a reasoning model called HRM, which is designed to solve complex problems through multiple steps. Instead of programming every step manually, we will be able to give the robot high-level instructions like sorting cubes by color. The robot would observe, reason, and act. This is the same general idea behind modern AI robotic systems. So what we built today is really the foundation: a robot arm, a physics simulation, and control code. In future videos, we will add vision, awareness, and AI reasoning. That is when things start to become really powerful. If you enjoy learning about AI and automation, make sure to subscribe. Please leave a comment, and I'll see you in the next video.